So this is number 1 from last night's homework, multi-step equations. 8x minus 6x equals negative 4. So remember, we're always going to follow distribute, combine like terms, bring all variables to one side, then solve. And so we came up with the silly acronym, donuts can be sweet, donuts can be salty, however you want to remember it. But we always look first to see if we can distribute. If we look at this problem, there's no parentheses, there's nothing to distribute, so we can skip that step. The next thing is combine like terms on each side. So let's look on the left side. I have 8x minus 6x. It turns out that those are like terms, so I'm going to put a box around each term. 8x minus 6x. Now my term is going to be something x. It's going to be 8 minus 6, which is 2x, equals negative 4. So now we've combined like terms on either side. Negative 4 on the right doesn't have anything to combine with it, so it just stays the same. B stands for bring all variables to one side. So identify where your variable is. We only have one variable, 2x. It's only on the left side, so there's nothing that you need to do with that. We can cross that step out. Finally, we're going to solve. We solve by using inverse operations. I have 2 times x, so the inverse of times is divide. So we're going to divide both sides by 2, and we're left with x equals negative 2. Now you should always plug back your answer into the original equation to make sure that it works. So if we're to do that, we're going to have 8 times negative 2 minus 6 times negative 2, and we want to see if it equals negative 4. Well, 8 times negative 2 is negative 16. Minus 6 times negative 2, that's negative 12. Negative 16 minus a negative 12, that's like negative 16 plus 12, is in fact negative 4, so it works. Alright, moving on to number 2. So I always write down my steps: distribute, combine like terms, bring variables to one side, and solve. Draw my line. Let's check if we can distribute anything. We can. We can actually distribute 5 times 3x. That should give us 15x. Then we have 5 times a negative 7. So that'll give us negative 35. On the right, we just have negative 140. So we've done our distribution. The next step is combine like terms on each side. So let's look on the left. 15x minus 35. Can we combine those terms? Well, 15x has a variable and negative 35 is a constant, so we can't combine them. And on the right side, negative 140 is just a constant. There's nothing to combine with it. Finally, bring all variables to one side. Well, 15x is the only term with a variable. It's already on one side, so we don't have to do anything with that. We just are going to solve. So let's go ahead, and I like to put a box around whatever's with my variable. In this case, it's 15 times x. That means that I'm not going to undo times 15. I'm going to look at this minus 35 and do the inverse, which is plus 35. That becomes a 0 pair and it goes away. We're left with 15x equals, then we have negative 140 plus 35. And this leaves us with negative 105. Finally, we need to divide both terms by 15. Don't mind my doggies barking at whatever's outside. Those cancel, and we're left with x equals, it's going to be a negative number. So let's see what you get when you do negative 105 divided by 15. Should give you negative 7. So we would say our answer is x equals negative 7. And I always recommend plug that back into the original equation and make sure that that actually works. Moving on to number 3. Let's write down our reminders. Donuts can be salty, or whatever you remember. Distribute, combine like terms, bring all variables to one side, then solve. Can we distribute anything? Well, I see some parentheses, so that probably means we can distribute. We can. We're going to do 7 times 7n. That'll give us 49n. Then we have 7 times negative 5. That'll give us negative 35. Now this plus 5n at the end of our equation just comes down, and it's equal to negative 251. So we've distributed everything we can. Next, let's see if we can combine like terms on either side. On the left, it's just negative 251. There's nothing to combine there. On the right, we've got 49 minus 35 plus 5n. There's definitely some terms we can combine. I see 49n plus 5n. Those terms both have the variable n, so that means we can combine them. So that'll become 49 plus 5, 54n, and then minus 35 stays the same. And all of it's equal to negative 251. So we've combined like terms. Now we're going to bring all variables to one side. Find your variable. There it is. That's the only term of the variable, so it's already on one side. We don't have to do anything. Lastly, we're going to solve. So 54 times n. So 54 is what we'll deal with last. We're first going to add 35 to both sides. And use your calculator. Even if you're doing this mental math in your head, still check your work in your calculator. So we've got negative 251 plus 35. So that gives us negative, I'm going to use this color, negative 216 equals 54n. Finally, we're going to divide both terms by 54. And you'll get that negative 4 equals n, or we could write n equals negative 4. And if we plug that back into the beginning, we would find that it's going to make our equation true. Moving on to number 4. So I've written out my equation. I'm going to write out my reminders, distribute, combine like terms, bring variables to one side, then solve. Or donuts can be salty. Did Chris bring socks? Someone came up with, do cats bite squirrels? I don't know, whatever you want to, however you can remember it. Let's look to see if we can distribute anything. Normally when I'm distributing, I have a quantity in parentheses and then a term in front of it or behind it. I don't see anything like that, so there's nothing to distribute. So let's try the next thing. Combine like terms on either side. Well, if we look at the left side, I have 8x and 3. 8x has a variable, 3 is a constant, so we cannot combine those. Let's look on the right side. 7x minus 5. Again, 7x has a variable, and minus 5, that's just a constant, so we can't do anything with that. Can't combine them. Bring all variables to one side. I have 8x on the left and 7x on the right. So we definitely need to do this step, bring all variables to one side. We do this by creating a zero pair. So a zero pair is when we use either the addition property of equality or we use the subtraction property of equality. You can pick either 8x or 7x to create a zero pair with. I always pick the one with the lower coefficient. So I'm going to make a zero pair with 7x. So what that means is I'm going to use either the addition or subtraction property of equality to get rid of 7x. Well, if I want to get rid of 7x from 7x, I need to subtract it. So we're going to subtract 7x from both sides of our equation. This allows us to cancel out that 7x, creating that zero pair. And on the right side, we're just left with negative 5. On the left, we're actually going to simplify. What is 8x minus 7x? That's just 1x, or x. And then plus 3 comes down. So now we've successfully completed that step and brought all variables to one side. Our variable is x and it's on the left. Finally, we're just going to solve. So I have x here, plus 3. Inverse of plus 3 is minus 3. I'm going to subtract 3 on both sides. We're left with x equals, those cancel, negative 8. Looking at number 5, let's write down our steps, distribute, combine like terms, bring all variables to one side, and solve. Draw our line, and let's check to see if we can distribute. We can absolutely distribute. I've got negative 8 times 7b. So that is negative 56b. Then I have negative 8 times positive 7. So that's going to be negative 56. Make sure my 6 looks like a 6 and not a b. All right, so we've distributed on the right side. Let's check, is there anything we can distribute on the left? No, so the left just stays negative 7 minus 7b. Combine like terms on either side. So look on your left. Can we combine negative 7 and negative 7b? No, they're not like terms. How about on the right? Negative 56b and negative 56. Nope, they're not like terms, so we don't need to do anything there. Bring all variables to one side. I've got negative 7b and negative 56b. Yeah, we've got b on the left and the right, so we're definitely going to do this step. So we're going to create a zero pair. Look for the smaller coefficient. So which number is lower, negative 7 or negative 56? Negative 56 is actually a lower number. Again, if you want to use negative 7, that's fine. I'm just always going to pick the lower one. So if I want to make a zero pair with 56b, I'm either going to use the addition property of equality or the subtraction property of equality in order to make this into 0. Since this is negative 56b, I'm going to add 56b to both sides. So this allows this to zero out, and we're left with negative 56 on the right. And on the left, we have negative 7. Then we have negative 7 plus 56. So negative 7 plus 56 leaves us with a positive 49b. All right, we've brought all of our variables to one side. Now we're just going to solve. I've got positive 49b. I'm going to get rid of this minus 7 by adding 7 to both sides. I'm going to bring my work over here. So I'm left with 49b equals negative 56 plus 7, which is negative 49. Now we're going to divide both sides by 49, and you get that b equals negative 1 for our final answer. For number 6, we've got this multi-step equation. Distribute, combine like terms, bring all variables to one side and solve. And we can definitely distribute. So first we have 3 times 3x, which gives us 9x. Then we have 3 times positive 3, which gives us plus 3. Next we have negative 6 times 1, which is negative 6. Then we have negative 6 times negative x, or negative 1x. This leaves us with positive 6x. And then finally, plus 8x just comes down. So we've distributed. Now let's check. Combine like terms on each side. 9x and 3 cannot be combined, so we're going to leave those alone. How about over on the right side? Is there anything we can combine? Absolutely. We can combine a positive 6x plus 8x. So negative 6 comes down, and we're left with positive 6x plus 8x, which is positive 14x. On the left, 9x plus, did anyone catch my error? I accidentally wrote plus 3. What I should have written is 9. So we have 9x plus 9. Sorry about that. All right, so we've combined like terms. Now we have b, bring all variables to one side. Doesn't matter which side you bring them to. I'm going to move whichever one of these is the lower coefficient. In this case, it's 9x. So I'm going to subtract 9x from both sides. Next, we're going to do plus 6 on both sides. So we have 15 equals 5x. Divide both sides by 5, and we're left with x equals 3. Always remember to take that final answer, plug it into the original equation, make sure it works.